All right. Thanks everyone for joining today. My name is Nick Gasky. I do client enablement and business development at Kaleido. We're going to do something a little different for those of you that have attended one of these in the past or had a one-on-one session with us. We're going to try to focus a little more closely on key management and some of the really flexible techniques that Kaleido allows you to employ. So before we dive into that, just want to share a few slides, give a little context about the platform to everyone, and then we'll just go ahead and hop into the product. Also, as we're doing this, please feel free to use the interactive chat that's available. Ask any questions. We have a few other folks from the team that are on, that are moderating, and then we can also unmute you if you'd like to actually ask a verbal question. So getting started at a high level, Kaleido, sort of three key definitions, characteristics that encapsulate the platform. Built for modern business networks, so very agnostic, use case industry, applicable to financial markets, healthcare, supply chain, government, public, private sector, you name it. Very, very simple in a good way. So whether it is configuring your actual blockchain at the node client and consensus level, or whether it's layering on services, those ancillary components that you're going to need to build out a solution. And then three, really built for the enterprise, disaster recovery, high availability, flexible approaches for key management, auto scaling, all of those built in as first-class citizens come out of the box, nothing that you as a customer, as a client have to configure or enable. This slide we like to use as we've been building out solutions with customers over the last 2.5 years. Something that became radically clear to us was that the blockchain piece, while incredibly important, it's your trust anchor, it's your indelible source of truth. Those nodes and those smart contracts, they comprise a rather small portion of the overall solution. You need a lot of answers around identity, around storage, around key management, digital asset modeling. And so we really see the stack sort of, comprised of these four primary layers, starting from the bottom up with data. What's going to be stored on chain? How is it going to be represented on chain? And then what's going to remain private and kept off chain? And then how does that data integrate with my back office systems, databases and utilities that I already have? Moving up a little higher at the transaction layer, with these, really unique use cases, a lot of times transactional privacy is incredibly important. You need flexibility in protocols and in consensus algorithms to perhaps give you a robust round of voting and digital signatures, or B, to have, state confined to a private Merkle tree. And then with those transactions, you need to consume, one or more events, very likely. So when you have counterparties that are invoking smart contracts on the chain, you don't want to have to go to, the actual blockchain layer to perform a programmatic query. You want to be, and you should be, automatically notified of those events so that your back office systems can process and react to them. Moving a little higher, we start looking at the need for perhaps oracles or the ability for apps to speak to each other, these messaging constructs. And then again, really starting to integrate with these connectors and these shims and middlewares to your back office. And then at the actual application layer, we start dealing with this whole new paradigm that is blockchain. Digital assets and tokens, whether they're fungible or non-fungible, cool techniques for masking and obfuscating identity with anonymity and confidentiality, so zero knowledge proofs. And then some way to really speak to the blockchain using constructs that have been tried and true, not using really thick SDKs and client libraries, but instead leveraging, message buffers and REST API layers, something that all enterprises and all developers are familiar with. So just a few key bullet points on Kaleido, and these will all become apparent as we dive in. But we can create a network in a matter of 30 seconds or a minute, built-in services for tokenization and swapping assets, cross-cloud and borderless, so we can create a chain on AWS or on Microsoft Azure, and those nodes can communicate and peer. The ability to decentralize and enforce governance and permissioning, a full stack marketplace with all of those components that we just looked at in the stack, and then some really cool innovations around, ZKPs and tethering private state up to the Ethereum mainnet. Just a handful of the clients we have and a good representation of sort of the eclectic use cases and the wide variety of, different industries that are leveraging enterprise Ethereum and Kaleido. So we see some major financial institutions, large energy companies, traders, retail, entertainment, et cetera. And then lastly, I kind of already hit on all these, but some good bullet points of objectively rated as a great blockchain as a service, those cool industry first innovations, enterprise in the DNA, and then cross-cloud borderless implementations. So as I said at the beginning, what we're going to primarily focus on today is around keys and just the different ways that you can integrate signing into your application or onto the server-side layer. Before we dive into all that, what I want to do is just walk through and create a blockchain and a business network really quickly, and then that'll provide some additional context to what we're going to actually do with these components. So our nomenclature for a business network is a consortium, so we can just call this, we'll call it 317 consortium, but this would define your business network. So this would be the supply chain, this would be track and trace, this would be capital markets, et cetera. And now we see we can set our home region using our cloud provider of choice and the locale of choice. So this will become a whitelisted cloud, a whitelisted region, and it will be available for us when we start creating nodes and services. So I'll use AWS in Columbus, Ohio. And now this is where we can make it that borderless or that hybrid blockchain. Bring on multiple regions in AWS, or even bring on an additional cloud provider in Microsoft Azure. So go ahead and click finish. And now we have the scaffolding. We just have this baseline namespace for our business network. What we want to do is we actually want to bring it to life by creating what we call an environment. And every business network can have one or more environments. So obviously you can create that logical separation for a DevOps pipeline. Have a dev environment, have a staging, a pre-prod, and then a production. So I'll create an environment, go ahead and call it development. That will likely be everyone's first environment. And now we can choose to scope it to any of those whitelisted regions as a single region environment, or we can make it a multi-region environment and allow us to have all of these as choices. So go ahead and click next. Now a great feature about Kaleido is we give you flexible choices with the node clients and with the algorithms. So if you want Geth, the Go implementation of Ethereum, battle tested and hardened on the mainnet, you can have that with proof of authority. Or if you envision needing private transactions or want one of these more robust consensus algorithms with finality, with 3 rounds of voting, and with a vast majority of digital signatures, you can choose Besu and Quorum with Istanbul BFT. So I'll use Quorum and Istanbul BFT. This is what we've seen as the most popular implementation combination out there with enterprises. So go ahead and click finish, and now you've created the Genesis block for your environment. You've actually bootstrapped that environment. And now we just need to bring it to life by adding some nodes. So we'll create node number 1. We see that I only have a single membership here. So go ahead and click next. And now we can weave this node in with some really powerful native cloud integrations. Specifically staying on the theme of keys here, what we can do is we can integrate our node's file system with a key management service, AWS KMS or Azure Key Vault. What this is going to do is it's going to use a master encryption key held in your own private service in a cloud HSM, and it's going to use that to encrypt on disk all of the critical keys that you need for transaction signing or for consensus signing. So this gives you root control, extra security for protection of those keys. And anytime Kaleido needs to make an API call out to get that key to decrypt, that will be auditable. So these keys are persisted to disk and ciphertext, protected by your own master key, and held in memory only when the node needs to run. A couple others, the ability to do log streaming. So taking your Geth, Quorum, or your Kafka logs and streaming those to a logging group so that you can build out your own powerful dashboards for troubleshooting or optimization. backups. So this gives you, the entirety of that file system, the level DB and the blockchain, all of the signing keys. And these can be, continuously scheduled, ad hoc, on demand. But the idea here is you have that assurance of business continuity. You have that extra redundance of your blockchain layer, of your node keys, and you can be assured that you can run this private blockchain, in your own private cloud on-prem, if you decide to leave Kaleido. And then lastly, optional private networking, maybe keeping a certain subset of traffic streams solely on the cloud backbone, not going through the public internet. So you can grab and choose any of these that you need. Today, I guess we'll just focus our eyes a little more closely on KMS and the power of that. And then lastly, choose the size of your node. So we can see some underlying performance metrics here, memory and CPU, but these also correlate to allowed concurrent connections and allowed requests per second. A small node is 5 and 5, medium and large are magnitudes higher. So if you envision, having a horizontally scaled application, needing very, very high throughput for your application, a medium or a large node might make sense. Finally, choose if you want the node to be a signer and click finish. So I'll just go ahead and add a couple more nodes to make the consensus algorithm happy. And then we'll hop out of this and look at some more interesting actual blockchain layer pieces. And I'm also going to add the caveat that I'm not working with the greatest of internet today in these new times where I think many of us are working from home. So if we do see a little bit of lagging or a little bit of spinning, just bear with me and we'll exercise some patience, because I can't guarantee that this will be the streamlined office internet that a lot of us are very used to. Okay, so these guys are taking a little bit to come up. Let's hop back to the business network level and look at two important things. So I dove into the actual blockchain layer very quickly. What we didn't do is we didn't really talk about the composition of the business network. Who's going to participate in this blockchain network, and how are we going to enforce that governance that I talked about real quickly? So there's two routes you can exercise here on Kaleido. The first is to create memberships that either belong to your organization or that you're proxying or operating on behalf of end participants. So we can see that my organization, I've chosen the very clever name, Organization ABC, has been provisioned the first membership. And what I can do is I can create multiple memberships that will be bound and owned by Organization ABC. So this is useful if I perhaps have multiple departments in my industry. Maybe I'm a large bank and I have multiple trading desks. It would make sense to have multiple memberships. And memberships basically are important in the sense that they are the object in Kaleido that gets bound to a node or bound to a security credential or bound to a service. So you can have that logical one-to-one mapping of, equities desk or, our currencies desk, for example, to a node and to a membership. So that's sort of the multiple departments proxy model. The alternate approach is to actually decentralize your network, kind of bring about the true ethos of blockchain. So maybe this would be organization 123, and you send an email invitation to the system admin at this company. And now you, as the founder of the network, as the initiator of this blockchain, you can actually enforce permissioning and governance. So you can choose to extend the full root level permissions that you have, or you can rescind or temper some of the permissions. And these are very, very self-explanatory. Do you want them to create nodes that can be signers, participate in the algorithm? Should they be able to manage environments, blockchains, upgrade those to new versions of the protocol? Should they be able to onboard organizations, create multiple memberships, or manage smart contracts? All of these are permissions that you can allocate or you can rescind. And the way this works is it's what we would call nested or hierarchical, meaning if this invitation went off, this organization could also extend these 4 permissions, but they couldn't extend the membership's permission. So it's very, very intuitive, very logical. So send that off, and if they accept, now you have the ability to decentralize your network. Okay, so that's really, really important stuff, but not the fun, super interesting stuff. So what I'm going to do now is I'm going to actually switch over to another consortium that I built this morning, and we're going to look at some techniques for signing. So the first one we want to look at is going to be external signing. So using one of those classic approaches with a thick client library with an SDK. So what I'm going to do here, just so everyone can stay on the same page of where we are, we're in a development environment in a different business network, a different consortium, and I'm hopping into node number one. So we see here node number one, I have all the low-level endpoints that I might need to build my application. And then we have this door here that we can use to connect through. We will touch on this door later. For now, we're going to go with the classic route through the JSON RPC Ethereum interface. And we're going to generate some, or we were going to use some strongly generated credentials. So everything in Kaleido, whether you're connecting to a node or you're connecting to a service, you do over TLS with strongly generated credentials that are obviously not stored by Kaleido. It's a salt hash verification on the back end, but this is used to provide secure connection. And these can be cycled. You can automate the cycling of those through an API, or you can use, the Kaleido interface to just manually recreate these or regenerate them as you need be. And what this endpoint will allow us to do, this will allow us to have that secure connection to the node and use one of these, what we call a Web3 client library. So JavaScript, Java, Python, Ethereum, what have you. So the first one we're going to do here is we're going to use a public repository that we have called Kaleido JavaScript. It's going to use simple storage, which is a very, very trivial smart contract. Has a single global variable, and it has a setter, and it has a getter right here. So two methods that we can use to, upsert a new value, and then a method we can use to query the state of that value. And what this program is going to do basically is it's going to instantiate this smart contract here, and it's going to use a externally generated Ethereum address and accompanying private key. And this is public for everyone to, download, clone on your machine, and interact with the various techniques and approaches there. So here we have the fully qualified endpoint, that RPC URL. So we're going to go into our program here that I have cloned locally on my machine. We'll invoke the program. We'll use the sign method. We'll specify that endpoint. And then we'll just ask it to deploy this smart contract. And if I got my syntax right, then this should work properly. So it goes and finds this local account that we have here on our machine. It's going to construct this payload, and then it's going to submit this payload locally into the network. So if we go to our home directory and we look at this hidden key store that we have here, inside of it, what we have is we actually have a JSON object with that account embedded right here, E4, ED3, and the associated ciphertext used to sign this object. So what we'll ultimately see here is we'll see a contract instantiation in our block explorer that has been signed by this Ethereum address. So that's the one classical approach that we give you out of the box to externally sign a transaction, easily deploy it into Kaleido. Obviously, you can use this approach, with your favorite library, with other development tooling such as Truffle, and you can connect via RPC or you can connect via your WebSockets. So if we hop out of this layer right here, go back to our environment and look at our block explorer, we're going to see a transaction creation, a smart contract creation from that address that we just looked at, 4ED3. So approach number one, classic external signing. I see that there was a question, so let me take a peek in the chat. Yes, we're going to give everyone a copy of the deck, yeah, we can expand, Sunny, on any of the pertinent technical layers. I know I have some stuff that I'm working on separately with you guys, so we can handle that offline. And please continue to use the chat if there are any questions, or if anyone would like more detail on a specific layer here. So number one, classic external signing using a Web3 client library that used Web3 JavaScript. Okay, So now we're going to take a step back and we're going to look at using the actual blockchain node to sign some transactions. And recall that this blockchain node could be additionally protected and encrypted using a key management service, Azure Key Vault or AWS KMS. Okay, so we'll go back to our business network level. And what we're going to do here is we're going to create a contract project. We're going to use that simple storage code and we're going to build an open API gateway. We're going to build an interface so that all of the nodes and all of the members in the network can have this, this concrete paradigm, this concrete interface that they can all interact with through. So we'll create a new contract project and we're going to call this simple storage. We don't need a description. And now we got to tell Kaleido how we want to create this interface. Do we want Kaleido to go and grab the source code from a public or a private GitHub, or do we want to supply the bytecode and the accompanying ABI? I'm going to go ahead and just let Kaleido compile this in a little serverless function and give us the interface. But if you wanted, you could, of course, just supply that raw bytecode and your own ABI. So click next, and now we need the path to where that code lives. So again, using our public repo here, Kaleido JavaScript, I'm gonna go ahead and grab simple storage. So I'll copy that, come back here, give Kaleido the endpoint to that .sol file. We'll give it a quick description, call it B1SS, contract to be compiled. There's only one in there, so we don't need to enumerate it. This guy is public, so we don't need a personal access token. And then I'll let Kaleido do all the auto detecting. So just go ahead and click build. And in a few seconds, we'll go ahead and have that bytecode and that ABI. All right, so that takes roughly 4 to 5 seconds. And we can see where it came from, and we can even see that git commit hash. And down here, we see our ABI and we see our bytecode. Now what we want to do is we actually want to take this and we want to build a simple API interface that we can use to programmatically interact through. So we're going to do that by promoting this to an environment, which in turn will create what we call a gateway API. So we'll click next. We'll call this simple storage for simplicity. And now we can promote it to one of our environments. And the idea here, this should make perfect sense, is that as you're doing your source code management, as you're iterating on an application or on a smart contract, oftentimes you're not going to get it right on the first go around, right? There's a lot of iterations that are going to take place. So within a contract project, what you can do is you can create, many compilations. You can promote those, turn those compilations into interfaces, into API gateways, promote them to your dev, your sandbox environment. And then once that code is hardened, once your application is behaving as you expect, take that exact same interface and promote it to staging or ultimately to production. And now what happens is your application layer, nothing changes there. It's just a simple update of an endpoint where you're actually pointing to on the back end of Kaleido. So it's logical sort of DevOps promotional pipeline here that we have. Okay, so what we've done is we've taken that bytecode, we've taken that ABI, and we've created a gateway called simple storage. And if we look at this gateway, it's going to have those core methods that exist inside of our smart contract. Really exciting, a set and a get with our global variable here, stored data. But this is just an interactive Swagger interface that we can now use to instantiate our smart contract. And we'll do that with the root post method. And what we're going to do in this portion of the demo is we're going to really look at this KLD from parameter. And this is going to tell this Swagger interface or your application where you want that private key to be derived from. What account are we going to use to sign this? So the first default one that we give you is just going to be that Ethereum count that you get for free on the node. So if we hop out of here, we go and look at our node number 1, our ABC interface that we deployed this through, we see that we have a default user account, 4B236. And we see that here in our wallet as well, 4B236. So first, let's just go ahead and use that to instantiate the smart contract. We're going to submit it synchronously, meaning that we're going to actually wait for that response to come back from Kaleido for this transaction to be mined into the block. And we're going to go ahead and register this with a human-friendly name. And what we're doing here is we're actually removing the whole Ethereum API. This Swagger interface is giving us kind of a transformation layer. It's giving us a shim. It's giving us a piece of middleware that's doing all of that critical heavy lifting for us. It's doing the nonce management. It's doing the RLP encoding. And it's transforming this, this simple JSON payload into a fully fledged hex encoded Ethereum transaction object signed by this private key. So no need to be, an Ethereum savant here using this this Kafka-backed ETH Connect layer that we have. You can just use standard web programming techniques, provide lightweight JSON payloads to your smart contract, and submit your transactions. So we see here that this has been instantiated using that private key. And maybe we'll just go ahead and take a look at this layer, since I kind of forgot to do that for you guys. But what we're looking at on the left over here, that would be our Swagger interface that we're with. But this could just the same be, a little node application with a Swagger client built into it. Just teach it about the APIs and the endpoints that you want to talk to. And then all you have to do is supply, lightweight JSON, providing the arguments to your method, submit that via this ETH Connect layer, either synchronously or asynchronously. And this will transform that little piece of JSON into a fully formed Ethereum transaction object. And using this approach, that object is somehow going to get signed on this server-side layer right here. What we did in that approach right there is we signed it with the Ethereum node, but what we can also do is we can integrate some other services. So we're going to show you a managed wallet service that we have. We're also going to show you an HD wallet service that you have. Great for anonymity, or great if you need to manage accounts on behalf of thousands of people and you want to map those accounts to real world end users. So lots of really, really cool flexible techniques to get that object signed over here on this side. All you're ultimately responsible for, at the application layer, is just specifying the account that you want to sign it and providing some proper JSON for those arguments. All of these nuances right here are taken care of. So let's take a peek at the chat for someone. Can we try it on a test net? Yeah, of course you can. So you can easily spin up your own little sandbox here on Kaleido. So we have a perpetually free starter tier. So literally create a Kaleido account, go ahead and use create your protocol and your consensus algorithm. In a matter of minutes, you're good to go to experiment with all these features. Okay, so that was approach number one. What we'll do now is we'll go ahead and we'll just, very, very easily create new accounts on, on our node right here. So you can do this via the Kaleido console, or you can do this programmatically using our Kaleido APIs. So every single thing that I've done in the platform, whether it was, creating the network or creating an environment or choosing our protocol, creating a node, etc., all of those are backed by really clean, really simple administrative APIs. So you can automate all of these approaches here. So obviously you can call new account in the console, but you could do that via our API as well. So here was the first one we had. Obviously we can go ahead and use this account to sign if we wanted to as well. So show you how easy that would be. Close out of this. We'll take a look at sort of the architecture of what we've just done here. So we had a gateway API that we called Simple Storage. We brought it to life using the default account on our Ethereum node, and that ultimately created what we call an instance. That created an instantiation of that smart contract. So now we can open this instance, securely connect to it again, view that API. We can do a quick query. We should see back 1, 2, 3, 4, 5 that we instantiated it with. And now we can use a different account to update the state. We can use that other Ethereum account that we just created on our node. So 0x116, and we're interested in, again, so that we're all on the same page, we're interested in this account right here. We're going to use that to sign. So we'll update our argument, give it 55. Now we can sign with that. So these are the very, very easy approaches to use the Kaleido managed wallet, the Kaleido node wallet to sign these transactions. What we want to look at now is we want to create our own, we want to use that get attach command, get into the JavaScript interface, and we'll create our own account, which we can encrypt with our own passphrase, our own password. So that's one approach. Then we want to look at the HD wallet. And then finally, we want to look at the managed wallet service. Once we run through those, we're going to have another one of our engineers on the call take you through a really, really cool feature, basically where you can integrate with your own IAM systems, your own user registries, LDAPs, and you can start defining rules for participants in your network. You can get really low level, really granular, and actually, scope the permissions down to specific smart contracts or even specific methods in those smart contracts. And I'll talk a little bit more about that here in about 10 or 15 minutes before he shows that. So just pressing forward with these different approaches, inside of my environment, what I have is I've actually created an HD wallet service. And inside of this HD wallet service, we have more or less an endless key tree. So we have about 2.7 billion accounts and corresponding private keys that we can easily fetch with the address and the private key, and we can use those to sign transactions. And what Kaleido is going to allow you to do is it's actually going to allow you to integrate this HD wallet service in that REST API layer, in that ETH Connect layer. So you don't have to make a manual call on the application side to query this private key, to query this address, and then build the object yourself. All you have to do is tell Kaleido about the HD wallet and about the index or the account that you want to use to sign. So what we'll do is we'll go ahead and use this approach, and we'll sign with this address right here, EDC, the default or zero index account. So close out of this. And what Kaleido needs to know is Kaleido needs to know the service ID, the resource ID for this HD wallet, and then it needs to know the actual ID of the wallet. So within this service here, we could create, many, many wallets. So if we maybe needed more than 2.7 billion accounts, we can just go ahead and, create multiple wallets. Or again, looking at sort of this bifurcation approach, if we wanted wallets for, different departments, we could logically create one for, our Americas desk or our European or Asian Pacific desk, et cetera. So lots of different approaches. Okay, so what Kaleido wants is it wants the service ID and then it wants the wallet ID. So going back into our gateway here, we'll expand our set method and we'll tell Kaleido that now we actually would like to use this HD wallet instance. So give it the service ID, go back here and give it the actual wallet ID. I think this is the one. And then tell it which account you want to use. Do you want to use 0? Do you want to use 123? You want to use 1,057? Any of these you can supply. So then go ahead and just update your variable again. Maybe we'll give it 99. And now we can use the HD wallet to actually assemble and sign that transaction object. HD wallets are great for a couple of reasons. Obviously, with 2.7 billion accounts, they're really useful for sign and forget, basically one-off signing for anonymity. But they're also really convenient for user account management. They're deterministic, and those accounts are going to appear deterministically in the same order with the same address and private key every single time. So all you need to do is just map off-chain your user registry, your accounts back to one of those indexes in the HD wallet. So this is a really, really cool approach here that is a recent addition to the platform. And then the last two approaches, we want to take a look at this Kaleido managed wallet service, something that we call an ETH wallet. I'll go ahead and deploy one of those as a service. And we'll just bind this to organization ABC right here. And while that guy's coming to life, I'll show you the final approach here, which would be to actually connect to the JavaScript interface, the JavaScript console on your node, and programmatically create a new account. So I'm going to clear that. We'll do a get attach right here. We're going to have access to all of those admin APIs, the guy we actually care about. We care about this personal class, and we want to call personal.newAccount. And at this phase, what you're going to be able to do is you're going to be able to actually set your own encryption phrase, set your own passphrase. And if we don't unlock this account, then it's not going to be able to be used to sign a transaction. So what we'll do here is I'll show you us attempting to sign with this account using that exact same approach that we've done a couple of times here. And we're going to get an error back from Kaleido saying that this account is... So again, forgive me for not having great internet. So we're gonna need to try that connection again. I was wondering when we were gonna get bit by the not great internet, but we've had a pretty good run so far. So we'll keep our fingers crossed. All right, let's try this again. Personal.newAccount. Okay, so we got one, and this guy is actually locked right now. So if we go back into Kaleido and we try to use this account, we're going to see an error. So this gives you, the ability to create those accounts, but then the ability to manage them and determine when they're allowed to use and who's allowed to actually unlock them. So if we call this post method and we now say, hey, I want to use this new account that I just created, we should expect to see an error. This 4D account right here, 4D. So go down here, we'll try to update this to, I don't know, 25 or something, running out of exciting authentication needed, password or unlock. So just another example of how you have heightened control to take care of those accounts. So if we actually want to, clean it up, we can just use our personal class again. I can type personal.unlockAccount, I believe is the API. So it's unlocked. And now if we actually try this call again, we should see it work. And then the last approach that we want to look at, so we see transaction success, is finally just this managed wallet approach, something that we call the Ethereum wallet. So that was what I just created. Go back into our environment. We see that we have an Ethereum wallet here. And inside of this, I'm going to be able to create accounts. There's a roadmap item that's coming that's really, really exciting, where these are going to be able to be integrated with some of those powerful cloud HSM services so that, the private keys in this layer never leave that piece of hardware. The object is assembled inside of it and then delivered back to Kaleido. Really, really awesome for, risk compliance and heightened degrees of security that are needed by a litany of industries here. But at its core, it's really just a managed wallet service that you can delegate signing to your own private, HSM utilities. So we see that we have a default address inside of here. We can create as many addresses as we need. And if we hopped back into that instance, that API Gateway instance, we could just use this guy to sign as well. So the takeaway here is that I believe we showed 6 different methods for signing transactions. Externally, default on the node, via the HD wallet, via a programmatically locked account on the node, and then via this managed wallet service. So that's pretty flexible, wide range of implementations that are available to you here on Kaleido. So we'll just go ahead and specify that account. Go ahead and just give this number 1 right here. And so we've looked at now all of those different possibilities. So depending on the security, the compliance that you need, or just the way that your application needs to be structured, or that you want to do key management, you have access to all of those approaches. Okay, so I have a bunch of other services that I kind of wanted to touch on, but I really would like Freddie, one of our full stack engineers at Kaleido, to walk you guys through this new feature. Just to kind of tee it up again, what we're going to show is we're going to show security integration with an existing IAM service. So you have a user registry, your Azure Active Directory, or your LDAP that you're comfortable with, and you have your usernames, you have your passwords, and what you can do now is you can start applying rules to those names. So you can start building out definitions of what they're allowed to do on Kaleido. Then you take those rules and you can map those to a configuration that you apply inside of your environment. So pretty much how this would work is we would build out this JSON object that has, rule 1, rule 2, rule 3, etc. And inside of those rules are what they map to. One could be an administrative permission, one could be, a read-write permission, and one could be, hey, you can talk to this smart contract, but you can't even write, you can only read from it. And then when users come in at the application level using a JWT, passing that in to authenticate to Kaleido, we're going to see what is embedded inside of that JWT, what rule do they have, and what are they trying to do at their application level? Are they allowed to do what they are attempting to do? So it's this really low level, really granular, bespoke permissioning. We have a bunch of documentation kind of walking you through it. We call it the blockchain application firewall. But it's really just, an integration with your IAM OAuth service, creating these JWTs signed by a trusted private key, and then inside of Kaleido, creating a mapping definition, a mapping object that informs Kaleido what those rules actually mean. When they see the JWT, what does that actually map to? So I'm going to pass it over to Freddie now. Is that okay, Freddie?
Yeah, it's perfect. Thanks.
Okay, cool.
Awesome. So let me start sharing my screen. Awesome. So yeah, thanks, Nick, for the explanation. So this is going to be a super simple application. The only purpose of this is to try to display the functionalities of our new feature of the BAF, as we call it, the blockchain application firewall. So as Nick was explaining, I'm going to go ahead and show you first an example of how this JSON file that Nick was talking about would look like. There's two sides for the blockchain application firewall. There's the authentication side and there's the authorization side. So one of the new features, something that this new feature is actually really good at, and my favorite thing about it, is to be able to authenticate users through a JWT token. The only thing that the node will have to, that will need to be able to authenticate the user is just the public key of any OpenID provider that you would like to use for your application. And just with that, the node will know that that user is authenticated. And now, adding to that, there's also a certain mapping rules, which is what Nick was talking about. So based on the role of the user that has been authenticated with the OpenID provider, it's going to be mapped to a rule set. So for the purpose of this application, it's just really simple. We're going to have 3 different users with 3 different roles. We're going to have an admin, we're going to have a vendor, and we're going to have a customer. The admin will be mapped to the rule set that we call admin. This is going to allow the user to do any type of calls to the node. The vendor, on the other hand, is just going to be able to write and read from the contract, but won't be able to deploy to the contract. And lastly, the customer just going to have read permissions for the contracts. So you can see here that the admin was mapped to the rule set admin. If you go to the rule set sections of the config, you can see all the rules that are specified for that specific rule set. In the admin, we're just allowing them to do everything. For the read, write, and no deploy, they can do call transactions to the contract, but they won't be able to deploy any new contracts to the applications. On the other hand, the only thing that the customer can do, which is to read only, is going to be to read from the contract. I'm going to show you a little diagram that the team created just to explain you how the flow of this short demo will be. I'm going to use a Keycloak instance that I'm running locally as my OpenID provider. So my application, what it's going to do is once the user comes to the application, it's going to be redirected to the Keycloak instance. Here, the user is going to input a username and a password. And if those are correct, the user is going to be authenticated and Keycloak is going to return a JWT token to my application. This is the token that I'm going to use to communicate to my node, passing through the blockchain application firewall. Once this is done, based on the role that the user is going to have on the Keycloak instance, the user will have certain permissions over that node. So I'm gonna go and transfer you to my application. This is just gonna be really short to try to, it doesn't really have any particular use case. It's just to try to show you and hopefully help you guys see what you can actually build with this new feature of Kaleido. So this is my application. We decided to do a mobile app just for try to do something different. Once the user comes here, it's gonna go and authenticate. What this is going to do is take my user into my Keycloak instance that I'm running locally, and here I have to log in. So I'm gonna. One thing to notice, this is a really simple application. This doesn't have a backend or database. So in order to deploy a contract, I'm gonna have to go ahead and create a wallet. Best thing will be to try to use any of the services that Nick was talking about, but this was out of the scope of this application. So every time the user logs in, we're gonna create a wallet, and that's gonna be stored in the cache of the mobile emulator. Once the user log out, this key is going to be deleted. It's not the ideal case, but just for the purpose of the application. The contract, once it's deployed, that contract address is going to be stored in the cache of the mobile, and that one won't be deleted for the other users to be able to have access to that contract address and communicate to it. So I'm gonna go ahead and create my wallet. As you can see, I'm logged in with a role of admin, going to deploy the contract, and I should have permissions to be able to communicate to my node and deploy that contract. So this is gonna take a couple of seconds. You can see that the deployment was successful. This is the address of the contract, and this address will be stored in the cache of my application and won't be deleted once I log out. The other action that I'm gonna go ahead and perform is the send transaction. This was just, oh, by the way, I forgot to tell you, this was just a simple storage contract, the same contract that Nick was using to do the other demos. It just has a getter and a setter. So in this send transaction, the only thing that I can do is go ahead and set some values inside of the contract. I'm gonna keep the value 8, call the transactions, and externally signing these transactions, communicate to my node with no logic whatsoever in my code. The only thing that I'm using is the JWT token that the OpenID provider returned to me. You can see the transaction was successful. And just to verify, I'm gonna go ahead and rip from that contract. I wanna show you guys how this looks inside of my Kaleido environment. This is the node that I was using to communicate with my application, just with the JWT, no upgrades or anything related to that. You can see in the block explorer 25 seconds ago that we created a contract and triggered a transaction. Now, when this hopefully will enlighten you a little bit, try to see the power of this. I'm going to log into with my vendor. They all have the same password, which is probably not the best thing. And as I told you, the wallet was deleted. Now I need to create a new wallet for this user. But the contract from the last user is actually stored. Just for a demonstration, I'm gonna try to deploy a contract with this user, the vendor, but without any logic in my application, the node is just gonna reject that call. He's not authorized because his role wasn't mapped to the rule set that allowed him to do this. And that's a really important thing. That's the only thing that you needed to be able to block any unauthorized calls to your node. And to prove that he actually has connection to the contract, I'm going to trigger a new transaction and modify the state of the contract. He does have permission to do this. It's gonna take a couple of seconds. The transaction was successful. We can read from the contract. The new value is there. As you can see, in my Kaleido environment, 9 seconds ago, a transaction was triggered on chain. Just lastly, hopefully it won't bore you guys because it's more of the same thing, but this is just to prove the concept finally. We're going to log in with the customer, which has only read access permissions. He's gonna create a wallet, try to deploy. This will fail. He can try to modify the state of the contract, but this should fail as well. It's unauthorized to do this, but reading from the contract is completely allowed to do. And this was just with no code in my application. This is just a really simple application. So hopefully that clears out the concept of what you can actually build on top of this new feature of Kaleido.
Awesome. Thanks for that, Freddie. Yeah, so hopefully everyone was able to see this is a really, really extensible, really powerful feature that's available here, allowing you to, not have security concerns about, those app credentials getting uncompressed and decrypted at your application layer, but instead using tried and true, OAuth redirect flows, authenticating to Kaleido with a JWT, and now giving you, really extensive low-level permissioning, role-based access control, that you can, modify, extend, rescind, and basically integrate with your tried and true, authentication flows using an OpenID service, using your IAM service, and OAuth. So I think there was actually someone had their hand raised. So let me unmute you, Thomas, so that you can ask that out loud. Okay, you should be good to talk if you want to say something, Thomas. Or feel free to just type it into the chat as well. Okay. So with the last few minutes, I guess what I'll do is I'll just go ahead and jump back into Kaleido, and I'll show you a couple more things that we have available. Um, One thing that may be really interesting to folks is, we're sort of just at that, baseline transactional layer and authentication layer that Freddie walked you through. But oftentimes I think it makes sense to take a big step back and see how much we can actually obfuscate the blockchain, and look at this through the lens of a user facing application, how this would be, applicable to, a healthcare use case, or supply chain, private data, et cetera. So what we have is we actually have a full stack application that leverages a good number of the features in the platform. It's going to use our document store feature. It's going to use the REST API gateway for injecting transactions, and it's going to use our event streams for consuming transactions. So just to give you a quick run through of what this is going to show, we're going to look at, a private data exchange. So we may need this, in with legal contracts. We may need this for land titles or for real estate. We may need this for pharmaceutical trials or healthcare provider records. There's a ton of circumstances where we're going to need, private data to be kept off chain, potentially referenced on the blockchain, and then shared with people in your business network. And what this is ultimately going to do, it's going to use our document store service that can be integrated with existing cloud storage utilities, Azure or AWS S3, and the existence of those files can be mirrored on Kaleido, right? We're going to provide you an interface allowing you to see those files, and ultimately allowing you to reference those files on chain via a hash, or perhaps more interestingly, transfer those files securely via that Kafka plumbing to another participant in your business network. And so this is, we don't think we have time to delve into the asymmetric cryptography here, but these will be securely transmitted. They will be encrypted and signed. They'll be chunked, they'll be compressed and enveloped. And you can ensure that, only the designated recipient of that is going to be able to decompress and decrypt that file. So this is the document store service. We'll use it to reference data on chain, and we'll use it to transfer data via Kaleido. I keep using the wrong window. Basically the certificates, those PKS7 certificates that we're going to use to encrypt, they live as key value pairs in our on-chain registry service. Tons of documentation on this, but really just, kind of a profile of an organization. What are the certificates? What are the keys? What are the addresses that we need to use for, this communication layer? Smart contract management, we looked at that. This is going to leverage that as well. REST API gateway for injection of transactions, and then moving the opposite direction, our event stream service for real-time notification of pertinent state changes on the blockchain. So it uses all 5 of these. And at the end of the day, it's just a way to integrate token economies, integrate a smart contract holding a reference of data and some metadata, and securely transfer those documents. So here's our environment. We have 3 organizations and 3 nodes. each of these has a document store service. So very, very easily, I could just go into here. I see I have an address book of my other organizations and their destinations. Think of this just like an inbox. And I can easily upload a document and then transfer this document just using the document store service, not even using it at an application layer. So I can click upload. I can go and find a file on my machine somewhere. Go ahead and use this private data file. And I'll do example private 11, just some dummy data. So we can create this in a subpath or a subfolder. Now I can upload this document and I can immediately transfer that document to anyone in my business network. So right here, we see that the hash, the deterministic hash has been automatically created by Kaleido when it's uploaded via the API. And now I can say, hey, I want to send this to org number 3 at this inbox, at this destination. Each of these only has a single destination, but you can imagine that they could have as many destinations as they need if they want to compartmentalize different documents or different business logic. So click send, and this guy will be kicked off via that Kafka plumbing. So all the sharding, all the encryption, all the signing is happening under the covers. And now we can go into org number 3's service, and they're going to have, inside of a received folder, they're going to have this document. So the transfer, sort of the semantics of that are very, very simple. They have it, now they can download it. But going a step further, we want to look at this at an actual decentralized application layer. So what we'll take a peek at here before we wrap up is those 3 organizations all running an application, all of them integrating those document store services, those RESTful layers and event streams layers and token layers into their DApp application here. So what we'll do super quickly is we'll just publish a piece of data. We'll publish that example private number 12 data. So give it some lightweight innocuous metadata here. Call this private data 12. And now we'll go ahead and select that file. So we see that we have it right here. I'm going to open that, and now I'm going to submit it. And what this is going to do, it's going to use that document store service to upload this file. It's going to hash it, and then on chain, it's going to put that hash along with this identifying metadata. So this is going to be an invocation to what we call our marketplace smart contract. And now, once that gets published, every other organization will be notified in real time via those event streams. So if I go into organization number 2 and I search for private data 12, we see that he's been immediately notified that this is available for purchase. So using your imagination, say that, org 2 has purchased a lot of data in the past from org number 1. They trust the integrity, the provenance of that data. So they're very, very eager to know when org number 1 is publishing data. So we've woven this example in with token economics. So each org has a balance. We see 680, we see 1560. So org number 2 has the ability to purchase this for 10 tokens. And again, this is going to use that document store service to securely transfer that document into this org service, at which point they have the ability to download that document. They also can rate it. So we can give it, a 5-star rating because we liked what we got. Again, this is an invocation of that smart contract. And now org number 3 should be notified in real time via those event streams that this private data number 12 was not only purchased, but it was rated 5 stars. So you can see how easily all of those low-level Kaleido APIs for transactions, for events, and for interacting with services can be stitched together in an application very, very easily so that we're using blockchain, we're using tokens, but we're not crowded and we're not overburdened with all of that, all of the semantics, all of the lexicon of blockchain, hashing, digital signatures, etc. We have a purely functional application here that we can use securely, privately, and with all the assurances of blockchain. So we're at the top of the hour. I'll take a quick peek at the chat if there's some low-level questions that we have here. Again, Santiago, so at the moment, what we have is we have blockchain, we have Kaleido available on Amazon and on Microsoft Azure. So these services, these nodes, these runtimes, they're fully managed by Kaleido. All of that is Kaleido managing the infrastructure, managing those pods and that auto scaling. So you have those two for choice. And we also have, you know, an early program called Kaleido Private Stack, where you can take a software stack and you can basically tunnel back into an existing Kaleido environment, an existing Kaleido business network, and you can run your node, your runtime on premise or in your own private data center. So please reach out to us if you'd like to discuss that more. You can always reach us, you know, inside of the product using the Contact Us feature, or you can reach us at support@kaleido.io. So I'd encourage everyone to, you know, sign up for an account if you haven't already. It is free to get started. And then we have a lot of, you know, really, really logical tiers as you need more functionality, give you access to, you know, more performance or more services. But we also have packages for, you know, startups, for innovation labs, something that's going to fit basically the point of your journey right now. So please, you can reach out to me directly, nick.gasky@kaleido.io, or you can reach our team, you know, via the website or directly via the product. We're happy to have, you know, one-on-one discussions with you, learn more about your use cases, and explore, you know, any of these features or any of the pricing packages that make sense. Yeah, so last question. Maybe we'll take this offline, Santiago, but there's not an intrinsic token on Kaleido. This is a permissioned private network. We have those token utility services that you can very, very easily use to model your own tokens, transfer those tokens, swap those tokens. But, you know, out of the box, you know, we do have Ether, you know, as a, you know, basically a network utility token that you can use with our Ether pool service, but there is not an intrinsic Kaleido token, so to speak. But happy to take that offline and talk more about that with you. And yes, Jordan, this is recorded, and you'll be able to go through these steps and kind of, you know, mimic your own application using our APIs and using those services. So thank you very much, everyone, for attending. I hope everyone is staying safe out there as we're adjusting to kind of these new workflows. And please reach out directly to me or to the broader team if you have any questions or would like to discuss technical or commercial arrangements. Thanks again, and we'll talk to you soon.